Hey, all you cool cats and kittens out there. This is Coach T with AP Microeconomics. Anyway, so we're going to continue on into imperfect competition, section 4.3 of this particular unit. And so here is the video lecture on oligopolies. I hate that we don't get to do this in class. Oligopolies to me are really fun to learn about. They're actually really easy to understand once you get the basics down, and it's really what we understand a lot of business to be nowadays. If we'll take a look at a few of the characteristics of oligopolies, there's going to be a few large producers, usually less than 10. I like to use the airlines as an example for oligopolies because that seems to make everything just kind of make sense. Or even like auto manufacturers. Think about GM and Ford, or Toyota and Honda and Nissan, that type of thing. They have identical or differentiated products, and that can be kind of one and the same, because if we looked at airline flights, well, that's the same product, but they're differentiated a little bit, right? And if we think about a four-door sedan, we think about a Camry or an Accord or a Maxima, an Altima, those are all three basically the same thing. In some cases, people might call those identical. They're a four-door car with four wheels on them and a steering wheel. In that aspect, they are identical, but they do differentiate them, based on how they look, the options that come on them, and that kind of stuff. Usually high barriers to entry. You're not going to just get in the airline industry. You're not just going to get in the automotive industry. They have control over price. They are a price maker. You know, the airline industry can set their prices. Automakers can set their prices because there's not very many producers. This is the key piece to an oligopoly, is this mutual interdependence. Okay? In other words, you rely on actions of your competition. Okay, they use very strategic pricing, and you have to be aware of how the other company is pricing their things, or what type of sales. Toyota has to be concerned about what type of sale Nissan's having. If Honda's offering a 0% financing, then you better offer something comparable, or you're going to kind of price yourself out of that market. So how does this happen? Well, if you think about the industries that I've talked to you about, this should just kind of make sense, right? They occur when there's only a few large firms that control the industry. They have these very high barriers, and there are different types of barriers. You've got economies of scale. It would cost you just way too much money to start an airlines, right? It would cost you way too much money to start producing automobiles. Okay, so it's hard to just jump into that particular industry because of the high startup costs. All right, and then in some instances, people own the raw materials. If you're talking about, oftentimes getting out of the United States, into some other markets, owning the raw materials makes you somewhat of a monopoly, but sometimes more than one company happens to own those. Okay, and so to look at oligopolies, we look at this thing called game theory, and to me, it's what makes this part of the unit kind of fun. Normally do some things in class. It'll be almost impossible to do here, but I'll kind of try and walk you through what may happen, right? And if you think about game theory, it is what it says it is, but it's calculated, right? Sometimes we play, basketball game and we're just kind of reactive. Game theory is more of a strategic type thing, and that's why you see the chess pieces there, because your move sometimes depends on what the other person's move is, and you're trying to put yourself in the best position, giving yourself the best situation to try and win the game. Okay, so we're going to use game theory to study how these businesses or how people are going to behave in strategic situations. Okay, and so if we can understand game theory, then we can see how an oligopoly may maximize profit. It may seem weird to you right now, but we're going to start putting all the pieces of that together. Okay, so game theory is kind of based on a concept created by a guy named John Nash. All right, and if you've ever seen the movie A Beautiful Mind, there's an econ piece in there where Nash and some of his buddies are at a bar, and there's some girls sitting at another table, and there's like four guys at one table and five girls at the other table, right? And then there's one girl that's the most attractive, and Nash basically says that sometimes you're better off making decisions based on what may help the entire group instead of everyone doing what is selfish. Okay, and his theory is that if everybody went after the really attractive girl, then all the others would be insulted and they would leave. Which, if everybody was acting in their own self-interest, that's what they would do. Okay, and so he believes that in business, kind of the same thing happens. Sometimes you can, if everyone acted in their own self-interest, it may not benefit everyone in the group. Okay, so apparently my buddy there is decided he's going to Facebook comment me. That's cool too. So let's talk about why we're going to learn about game theory. Well, it shows this interdependence that we talked about a minute ago, and as we're anticipating, we're reacting to the decisions that our competitors make. Okay, so in an oligopoly, pricing and output decisions must also be strategic. Okay, so they can't just always go by a graph like we've been learning graph. Here's the profit maximizing point. This is going to be our price. This is going to be our quantity, because they're concerned at what another business is going to be doing. Okay, and we're going to look at kind of how that works. So it helps us determine how businesses are going to figure out what their best strategy is going to end up being. Okay, so in other words, game theory helps us predict human or business behavior. Okay, if we were in the classroom, we'd have a little fun with this called the ice cream simulation. So you're an ice cream salesman, you're at the beach, you have identical prices as another salesman, so you got these two salesmen, and people on the beach are going to purchase from the closest ice cream stand. Okay, and so if you can imagine this beach front where people are just spread out evenly all along, and in each morning these guys come out and they got to figure out where they're going to set up their ice cream stand. Okay, where would be the best location? All right, and generally what I would do is I would take and I'd put this up on the board, and I'd have some people come up and place their sticky note on the board as to where they may set up their ice cream stand. Okay, and generally what you end up figuring out is that the best place for these people to end up setting up are side by side of each other, right? Because then it's an equal walk for everybody on the beach. So instead of trying to get all the way over to one side where you may eliminate some customers to your left and giving all the business to the right, you got to kind of get in the middle. All right, and what we find out is when we run this activity, that both people end up getting right side by side of each other in the middle of the beach. And if you did that every day, that would kind of end up just being their spot, right? So let's say they started out on each end and they gradually work together. They would end up figuring out that they'll maximize profits as they made a decision that ended up helping both of them. Okay, we see this. Notice it's down here. It says, "How is this observed in the real world?" Okay, one thing we always talk about when we talk about real world with oligopolies and with this strategic location type problem is if you look at strip malls, if you look at some of these shopping centers, you will always see, or you will generally see, it's not always perfect, but you'll see some of the same businesses kind of setting up side by side by side, right? You get out on Barrett Parkway, you see all the car dealerships are kind of in one general area, right? Sometimes when you see a Publix parking lot, or I'm sorry, a Publix grocery store, all of the stores around it are the same thing as they are in another Publix shopping center, right? They always have a Mexican restaurant, they got a dry cleaner, and so all of these firms have kind of made this decision as they are interdependent on each other, okay? So one of the fun ways that we do this is we practice what's known as a prisoner's dilemma. All right, this down here you're going to come to know as a game theory matrix box. Okay, if you get a game theory matrix question or FRQ on the exam, you need to celebrate because they are really, really easy, right? In the beginning, the first time or two, they're a little tough to get. After that, they start clicking, okay? And I got about 3 minutes to go. I'm going to try to get through this one, and then I'll start another video kind of as we go on. So prisoner's dilemma is basically where you have these two prisoners that have one or two choices. They either have to deny or they have to confess. So they're in different rooms, they're getting interrogated, and they have to decide whether they're going to deny or confess. All right. Well, prisoner one, let me get all this here plugged in here. Okay. If both were to deny, then they would each get 5 years in jail. Okay. If they were both to confess, okay, each would get 10 years in jail. All right, so if they both denied, they get 5 years. If they both confess, they would get 10 years. Now, right there, we would say, well, you know, kind of the smart thing to do here is let's both just say that we didn't do it. Now, they can't cooperate, right? They can't talk to each other. But we can see where that particular combination is the best one for the group. All right, well, let's look and see, well, what if one of them cheated on this thing, okay? In other words, if prisoner one confessed, he would end up going free, and prisoner two denying would cost him 20 years. So where this ended up being the best scenario, it turns into a scenario where it could really hurt you, right? Well, it flips on the other side over there. If prisoner two were to confess, they would go free, and if they denied, it would be 20 years. All right, and now all of a sudden we get that information, and we see that maybe if they both confess, right, that may end up being the best scenario, right? Individually, selfishly, you want to confess and hope that the other person denies, thinking that if both denied, they would get the 5 years. So you can see an incentive now to undercut the other person if you're trying to think what they're going to do in some type of rock, paper, scissors strategic thinking. All right, and so that's kind of the basics on a prisoner's dilemma. This is a game theory matrix, and obviously if we were in class, we'd have a little fun with this. You guys would partner up. I would make you guys go through the prisoner's dilemma, and you would find out that your friends maybe aren't as friendly as you thought they were. So anyway, I'm going to stop this video, and I'm going to come right back with another one behind it as we're going to look and see how we use game theory matrix in economics. So see you back in a few minutes.